All right. Number 20. Given f of x, find the value of k. So write this in vertex form. What would this number be? So we are going to complete the square to write it in vertex form. Minus the 23 over. And so on the right is just this. I'm going to factor the 2 out. X squared minus 6x. And now I'm going to complete the square. Half of 6 is 3. 3 squared is 9. We've added 9 inside the parentheses, but to the right-hand side, we've really added 18. And so now we have f of x minus 5 is equal to 2 times x minus 3 quantity squared. And then I'm going to add the 5 over to the right. So the k value would be 5. I suppose you could have also used negative b over 2a to give you the x value and then plug it in to find the y value. So that would be 12 over 2 times 2 is 4. So x is 3. 2 times 3 squared minus 12 times 3 plus 23. That's 9. That's 18 minus 36 plus 23. That would be negative 18 plus 23, which is 5. So that told us that the vertex is 3, 5, which we know that number is this number if I take this and write it in vertex form. Number 21. Write the equation in vertex form and in factored form for each. Okay, so let's do factored form. This is crossing at negative 1 and 3. It's going up, so it's positive, and the a value is 1 over 1, up 1. So this up 1, that represents a, like when you're graphing 1, 1, 2, 4, 3, 9. So a is 1, so I don't need to write the 1 in front of the parentheses. X plus 1 times x minus 3. And then vertex form, the vertex is 1, negative 4. So vertex form is x minus 1 squared minus 4. And this one, factored form, it's crossing 2 and 4. And it's upside down, so it'll be negative. And the a value is 2. It's going over 1, down 2. So negative 2 times x minus 2 times x minus 4. And vertex form, its vertex is 3, 2. So vertex form, f of x is equal to negative 2 for the same reason. It's opening down and the a value is 2. And vertex form, so x minus 3 squared plus 2. Find the vertex and the x-intercepts of each parabola. So I want to remind you that you get to use those graphing calculators, and so that would be a way to double check yourself, because it will find the vertex and the x-intercepts. So we learned that after you graph it, you press F5 for G-solve, and then if it's a parabola opening down, I would press max. If it's opening up, I would press min, and that gives you the vertex. And then if you hit root, that gives you the x-intercepts. But I don't have that here, so I'm going to do it longhand. Find the vertex and the x-intercepts of each. Okay, so the x-intercepts, I find the x-intercepts by putting it in factored form. That's what factored form does. And when the front is negative, you don't ever want to try to factor with that. So what we do is we just factor the negative out. X squared minus 8x plus 12. And now it becomes much easier to factor. Two numbers that multiply to 12 add to negative 8. So that would be, what would that be? Negative 6 and negative 2. Adds to negative 8, multiplies to positive 12. So the x-intercepts are 6 and 2. And the vertex, I'm going to use x equals negative b over 2a. Negative 8 over 2 times negative 1. Negative 8 over negative 2 is positive 4. And now I'm going to plug 4 in. Negative 4 squared plus 8 times 4 minus 12. Negative 16 plus 32 plus 12. 16. I feel like I did something wrong. Oh, it's minus 12. Minus 12. Minus 12. So 16 minus 12 is 4. So our vertex is 4, 4. What am I trying to find? Oh, the vertex. Vertex 4, 4. Second one, it's telling me the x-intercepts right now because it's in vertex form. X-intercepts are negative 1 and negative 5. Did I say vertex form? I meant it's in factored form. So how do we find the vertex? I'm going to multiply it out so it's in standard form. I'm going to leave that negative sitting there, and now I'm going to FOIL. Outside is 5x, inside is 1x, so that's plus 6x. 1 times 5 is 5. And now I'll distribute that negative. Negative x squared minus 6x minus 5. So now I can use negative b over 2a. So 6 over negative 2 is negative 3. So the vertex, negative 3 something, and now I plug it in to standard form right here. So that would be negative 3 squared minus 6 times negative 3 minus 5. Negative 9 plus 18 minus 5. 9 minus 5 is 4. So our vertex is negative 3, 4. This is in standard form. Again, it's negative, so I'm going to factor that out. Minus 4x plus 3. Now I can factor that easier. That would have to be a minus 3 and a minus 1. So the x-intercepts are positive 1 and positive 3. And the vertex, using standard form, I'm going to negative b over 2a. 2 times negative 1. Negative 4 over negative 2 is 2. And the x value is 2. Now plug it in. Negative 2 squared is 4. Plus 4 times 2 is 8. 4 minus 3 is 1. So 2 comma 1 for the vertex. And we're in vertex form, so the vertex is -4, 1. And now I just need to find the x-intercepts. So I could FOIL this out to put it in standard form, and then and then factor it. Or what you can always do is set the y value equal to 0 and solve it. So 0 equals negative x plus 4 squared plus 1. I'm going to minus the 1. And both sides are negative, so divide both sides by -1. We have 1 equals x plus 4 squared. And now I'm going to take the square root of both sides. So then I would have x plus 4, I'm just switching sides too, x plus 4 on the right, which I'm writing on the left, and the square root of 1, don't forget your plus or minus, is 1. And minus the 4. So our x-intercepts are -4 plus 1 is -3. -4 minus 1 is -5. All right. Write the equation for a parabola with a vertex and passes through this point. So vertex form for a parabola, x minus h squared plus k. So our vertex is the h and the k, and this is just some random point. That'll be x and y. Because for vertex form, we need h and k, and we also need a. So I'm going to plug all those in to solve for a. So y is 3 equals a times x is -7 minus h is -5 squared plus k is 1. So inside those parentheses that'd be -7 plus 5, which is -2. -2 squared is 4. So we have 3 equals 4a plus 1 minus the 1, 2 equals 4a, divide the 4, so a is 2/4 or 1/2. So now I can write its equation now that I know what a is. 1/2 times, or I'm using our vertex, so x plus 5 plus 1. A parabola has x-intercepts and goes through this point, so this is just some random point. Are these following points also on the graph? So I need to write its equation so I can check that these points are on it. So they're giving me the x-intercepts instead of the vertex. So my form is going to change, my formula. So it'd be a times, and we use different letters for inside the parentheses. I think it's p and q is what we use. Minus p minus q. So the -2 is p and the 5 is q. And I'm going to do the same thing as in the last problem. I'm going to plug everything in to solve for a, because I don't know what a is. So y is 9 equals a times x is -4 minus -2 times x is -4 minus q is 5. -4 plus 2, so that's -2. That one's -9. -2 times -9 is 18, so we have 18a. It looks like we're going to have a is 1/2 again. So our equation 1/2 times x plus 2 times x minus 5. So that's our equation. So I need to see if these points are on that parabola. So I should have written f of x instead of y. It doesn't really matter, but we plug in x to see if we get that output y. So I'm finding f of 2. So I'm plugging it in there. 1/2 times 2 plus 2 times 2 minus 5. 1/2 times 4 times negative 3. 1/2 times negative 12 is negative 6. So when we input 2, the output is negative 6, and that is yes, so yes on this one. It is a point on the parabola. Let's check this one. F of negative 3, 1/2, oops, 1/2 times negative 3 plus 2 times negative 3 minus 5. Negative 1, negative 8, half of 8 is 4. So when we put in negative 3, the output is 4. This says negative 3, 5. So this one is a no. Number 25, compare the axis of symmetry and the minimum values for these two functions. All right. The bottom one, J, is in standard form. And this guy is, the first one is in factored form. I'm going to multiply that out so I can get it in standard form. I'll distribute the 2 last. I'm going to FOIL x plus 3 times x minus 7. X squared minus 7 plus 3 is minus 4x minus 21. And 2x squared minus 8x minus 42. And what do we need? What are we comparing? The axis of symmetry and the minimum values. So I need the vertex. So I'm going to use negative b over 2a. Negative b over 2 times 2. So x is 2. And plugging in a 2. 2 times 2 squared minus 8 times 2 minus 42. That's 4, so that's 8 minus 16 minus 42. Negative 8 minus 42 is negative 50. So that means our axis of symmetry, which that's what it told us to compare, the axis of symmetry and the minimum values. Axis of symmetry, the x value was 2. Axis of symmetry is x equals 2. And the minimum value was negative 50. I just put m for minimum. Now we got to figure that stuff out for j of x. Negative x equals negative b over 2a gives us x equals 2. So this one's axis of symmetry is x equals 2. And plug it in. 2 squared is 4, minus 4 times 2 is 8, minus 21. Negative 4 minus 21, jumping ahead, is negative 25. So its minimum value is negative 25. The functions have the same axis of symmetry, yes, but the minimum value of h is less than j. Negative 50 is less than negative 25. That one's correct. Same axis of symmetry, but the minimum is greater, so no. Do not have the same axis. Do not have the same axis of symmetry, so just A. 26. Given the diagram below, Approximate to the nearest foot, walking saves by, okay, so this person walks across the lawn and it's 60 feet. If they walk along here, how many feet is that? This distance is x, this one is x plus 12. So we're going to use, if you remember, this is a right triangle, so we can use the Pythagorean theorem. Side squared, a squared plus b squared equals c squared. So we would have x squared plus x plus 12 squared equals 60 squared. X squared plus, I'm going to FOIL that out, it's x plus 12 times x plus 12. X squared plus 12x plus 12x is 24x. 12 squared is 144. 60 squared is 3600. And that's 2x squared plus 24x minus the 3600, so minus 3, 4, 5, 6 equals 0. So I got everything on one side. And looks like I can divide all those by 2 because we're in an equation and the other side is 0, so that is a legal move. So now we have x squared plus 12x minus 1728 equals 0. And I could factor this, or I could use the quadratic formula. Quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Alright, so we would have 144 minus negative. We do that in our calculator and it came out to be 7056, the square root of that number. Then find the square root of that number and it's 84. So we have negative 12 plus or minus 84 over 2. So we have negative 12 plus 84 over 2, or negative 12 minus 84 over 2. Negative 12 minus 84 is negative. This is a negative number, so I disregard this because distance can't be negative. Negative 12 plus 84 is 72 over 2 is 36. So x is 36. And so that's this side of the walkway. And x is 36, so 36 plus 12 is 48, is this side of the walkway. So the person walked 36 plus 48 is 84. The question was how much more, how much they save by cutting across. So if they walk this way, that's 84 feet. And if they cut, it's 60. So I find the difference, and that's 24 feet. Alright, I think I'm going to cut the video there. It's been 18 minutes.